I guess we have made that instance over there. Now I will try to show you how to maybe take this. Now we are into maybe building phase, no? So we have to build algorithm for it, and that algorithm can be a built-in algorithm. That algorithm can be our custom algorithm. Okay, and then before choosing an algorithm, we need to understand this problem completely. Okay, so based on this problem, we can say this is an image classification problem, and we have to use an image classification algorithm, because what we have to see in images, either that image is having cancer or not. Okay, so so it is a type of supervised learning algorithm, and then the task is very clear: take an image as an input, and classify it into maybe one of the multiple output categories that can be cancer or not cancer. Then we have uh, uh, these image classification algorithm uses CNN, ResNet and other thing to maybe do its work. Okay, to maybe classify either there is a cancer or not. Okay, so as I told you, it can be done in two ways. As always, a full training mode or maybe transfer learning mode. In transfer learning mode, you will get some of the pre-trained algorithms, and you have to use them. And in full training mode, you have to update your own weights and biases, and you have to maybe do everything from scratch. Okay, so I have written some of the points in the notes section. You can go through these points, and then need not to maybe again narrate these points. Okay, so now you can do it in two ways, but again, uh, how you will formulate the input. So the input can be formulated in two ways, and there are two valid approaches. One approach is either you will get the raw image into JPEG or PNG format, and the second approach is you will change the data points into record.io files. Okay, and then you will use record IO files for MXNet. Okay, so I will do that because this is always recommended. Don't play with raw images. Okay, just change them so that those images will be easy to interpret. Okay, so uh, I have written some of the pros and cons of the above technique, maybe using the raw images and using the record IO images. So if you will use the record IO, then what you can do is you can use AWS SageMaker pipe mode. Okay, and this is very useful. Okay, otherwise you have to use the, if you will use raw images, then you have to use the file mode, and this is very cumbersome and time taking. Okay, so I have given some of the points why this is cumbersome, and what are the problem with it, and then again why to use the pipe mode and stuff. Okay, so then we have hyperparameter to update in, like what will be the hyperparameters. So some of the hyperparameter is number of training samples, like how many training samples will be there, and number of classes. Okay, so there will be two classes, 0 and 1, maybe no cancer and cancer. Okay. Then you will have to use some of the built-in APIs. Okay, so I have written over here is SageMaker provides two APIs for building model. So MXNet is a built-in model which you will get inside maybe your notebook instance. I will maybe make sure that you will understand when we are using MXNet. So don't worry about it about that. Okay. So building model using built-in algorithms, that is low-level AWS SDK. Uh, so this is the development kit for Python, and high-level SageMaker Python library. Okay. So what I have done, I have written code for both, and you can go with both the code. Okay. I'll share the code. No worries. Okay. So I guess this is all which we have to cover in theoretical section. Okay. So let's maybe from the next video I will try to show you how to use maybe built-in algorithm and how to use custom algorithm. I will use TensorFlow for that. Okay, and then what I will do is from here I will try to maybe explore some of the images, and I will try to upload them to the S3 bucket, I will try to change them to the required format, that is RecordIO format, which is required by MXNet. And after that, maybe we will work with it. Okay. So why we are using S3 bucket over here is we will put all the pre-processed image, we can say, or the transform image into that S3 bucket inside train and test folders, and then we can train on train dataset, and we can maybe look for our result on what we can say, uh, test dataset. Okay. So this is the maybe this is the journal flow, okay. So this is the journal flow which people generally use, maybe in their uh, what we can say is journal deep learning life cycle. Okay. So one more thing I want to include is, if you will use MXNet, then you have to convert those images into record.io format, and then if you will be using TensorFlow, then you can maybe change those images into TF record format. Okay, so you have to keep these two things in mind. For MXNet, because this is the built-in thing, then you have to go for record.io format. You have to change the images to the record IO format. And if you will use maybe TensorFlow, and maybe this will be what we will do is we will make our own algorithm in TensorFlow. So for that you have to convert your images into TF record format. Okay. So now what we will do, we will configure image classification, then I will try to maybe convert images to TF record, and after that record IO based on which kind of algorithm we are using, built-in or maybe custom. And after that I will try to configure TensorFlow, and maybe I will try to configure this MXNet, which is built-in algorithm in Sagemaker. So I will try to configure them, and I will try to show you how to configure these algorithm estimator using the high level uh, SageMaker Python libraries. Okay, so this is all for the theoretical section, and just I was convinced to cover or to tell you what we will do in the upcoming videos, and because now from here onwards everything will be much into implementation part, and there will be a plethora of code. So just uh, be chill, and try to understand the code. I will try to make you understand every step in the code, and let's see, try to maybe get max out of it. Okay. This is all for this session. I will stop it.